This is week 13, Monday. This is Thanksgiving week. Tuesday we had a full day of tech den. We had Unreal Engine and Blender. But today we're talking about Bca-101, Information Computers and Information Systems. Networks and Security, Business and Technology, New Current, Work, Microsoft Access, First Look, Databases. Are you working through the course materials? Of course, should be. First thing we talk about, this is sometimes referred to as a full stack. Anyway, users nowadays experiment or experience a lot of material via the internet. So we have the front end. So we have these web browsers, right? You have your view either through a browser or some kind of app using networking to communicate. User interface, user experience. In this case we're talking about the web. Then we talked about a database that you might be interacting with. Storage, we call this the back end. Using this all the way through, or being able to do all of the programming on this end and the design on this end, is called a full stack. This is the front end that we see. This is often referred to as the back end, the coding that makes it work. So when you go to a website and you fill out some type of form and click submit, it writes it somewhere in a database that later on can be accessed when you go back to the same site. Stuxnet, we talked a little bit about viruses. So we talked about the plus to hacking and the minus to hacking. Whether you consider this a plus or not, this was a virus or worm, or I'm not sure exactly, malware of some sorts that infiltrated the Iranian centrifuges to extremely slow up their production of a nuclear bomb. Interesting. Alright, then we have a little bit more about security. So, in this case, we were saying if Zach wants to send a message to Matt, we're going to talk through this. So, first of all, if we want this message to be secured, okay, so this is for encryption, we can have public and private keys. We can have a key pair. Encrypt it with your public key, you can only decrypt it with your private key. Okay? And vice versa. Encrypt it with your private key, you can only decrypt it with your public key. So here's our first scenario. We want to encrypt the message. So Matt sends his, that's the first thing, sends his public key. There's an I in there. Sends his public key to Zach. Zach uses it to encrypt the message, so he encrypts the message and sends it to Matt. Now Matt can decrypt it with his private key. Okay, so that'll work. Since Matt's private key, okay, is the only one, he's the only one that has that, so he's the only one that can decrypt the message that was encrypted with his public key. So we have a key pair. Now Zach can have a key pair. Okay. So what he can do Well, let's go another step. Let me use yellow. Another thing we can do is we can hash the message and send it over, the hash, when we send over the encrypted message. Okay, so now we have the encrypted message and we have the hash, and then of course we already mentioned with his public key, because it was encrypted with his public key. Matt can decrypt it with his private key. So here he has it decrypted. Then, believe it or not, then he can hash it. Here's the hash. And then he can compare the hashes. If they match, this message couldn't have been changed. Okay, so now we have an accurate message, and it was encrypted so nobody could see it. The final thing. Okay, I'm going to use blue for this. Zach, let's start again here. Zach also has a public and private key. So he can take this hash and encrypt it and also send that over. Okay, and he'll encrypt it with his private key. Alright, he encrypts it with his private key. So now he also then can send his public key over. So Matt can decrypt it with the public key, and then of course he can check it now with the hashes. If they equal, then the message had to come from Zach. Interesting. These two little letters in here. There is a way to set up a public and private key on each end using something known as the Diffie-Hellman. Those are two different people, Diffie and Hellman, who created this algorithm in which you can exchange some information and keep some information private, and you can set up a key on each side. So that's often used in things like VPNs or other ways of securing connections between two places, like you're using HTTPS. Wow, that was a mouthful. We better go. Levels of business management. We talked about the workforce. Yeah, we mentioned here's me, workforce. Then we have people who oversee the workforce, first line supervisors. Then maybe middle management oversees the first line supervisors, and then we have top level management. So here at the college we have faculty and staff and so forth, and then we have people who oversee faculty and staff and so forth. Then we have some middle level managers. You might think of them, we have some VPs, and then up here, top level management, we have the president and maybe a couple key vice presidents. Okay? And above there is the board of directors. Similar a lot in businesses. So we have a flow of information that moves between these people. How do we manage that? Well, let's take a look at it over here. We collect large amounts of data, typically through transactions. Okay, so this over here would be levels of information, info. That's why we call it a management information system. So let's look at that. So we have large amounts of data. We started our database where we have United States, and we did queries on the United States, and we did ad hoc on the United States to send information to different people in the organization. Or these people could be internal, you know, people running the company, or we could send information to people external to the company. Like you coming in a website, like we showed earlier, and getting some data from here. Some information from the company. So, transactional. Typically, first line supervisors do transactional type things. Let me use a different color there. That makes sense? Now, tactical information. We have less information. We're getting smaller. We have less information. But it's used to make week in, week out decisions, or maybe decisions based on the season of the year. We sort the information into even a smaller amount up here for the top level management to make strategic decisions, like what are we going to do in the next year, 2 years, 3 years, and so forth. And the movement of this is an information system, or sometimes referred to as management information system. A management information system. We're still on week 13, the day before Thanksgiving. Review this, talk about decisions, data in a database, and we get started on the group work. First of all, I talked about they call this the 4 C's of the 21st century. You'll see I listed 5. Okay, communication, critical thinking, creative work, and collaborative work. You'll read or see people talk about 21st century. You got to be able to, we always have had to communicate well. You got to be a critical thinker. You need to be able to collaborate with people, and got to be creative. Last one, I put computational thinking. I think you have to be able to do computational thinking. You got to think a little more of how we manage so much data in the world. So this part of the course should be hopefully interesting. Let's take a look here. I missed one. Yeah, here we go. We reviewed levels of management. That's a workforce, that's West Fork, the high school, that's a workforce. Different levels of workforce, and then we have data, and from there we send information through tactical, strategical, or day in, day out work, weekend or seasonal, and this is long range decisions. And we have different levels of management work with different levels of information. So I used the example of Canvas. Canvas, we keep track of grades, and eventually we have to move those grades from Canvas to where they're kept permanently, Colleague or whatever the fancy software is. We also keep attendance. This has a lot to do with financial aid. So we keep track of students, faculty, staff. Just as an example, we keep track of courses, what sections are being taught, keep track of financial aid, and this is kept track in a relational database management system. So, what do we use the data for? Lots of things. Lots of things. So, we are going to move to the next slide. Before I do that, do you think about that? We have all these different entities at the college, things we need to keep track of. I'll give you a good example. If you're not getting good enough grades, you might lose your financial aid. Okay. Here's a little example. We made this chart here. This is, let me draw over this again. So we have a graph, and as an example, let's say we're recording. The example I used was pudding. At the pudding plant, they're putting pudding inside the containers, and you're measuring it. You have some computing device measuring that, and all of a sudden you notice you're putting more pudding. And these are your standard deviation, and as long as you're inside the standard deviation, everything's okay. But as soon as you get outside of that, there's something you need to do, because you're either putting too much or not enough. For example, if we were down here, we're not putting enough pudding in the jars. As long as you're in here, you can advertise, what, 8 ounces or whatever. A second thing, this tells you something. When you get 5 readings or more on one side of the average, it's probably telling you something's wrong with your equipment. You're putting in too much pudding. So at some magic number, let's just say 5, you can have the computing system automatically stop production, and you can check to see what's wrong. So we're making a decision. Okay, we're making a decision based on data. Very important. Let's talk a little bit about that. We're going to talk about data-based decisions. Okay. 3 more slides. Actually, 2 more slides. So, we have all kinds of data, all kinds of people. We have internal people, then we can have external people seeing our information, and we can make decisions. Some decisions are structured. We reach a certain point and we do something. Some decisions are non-structured or unstructured. And then we have a range in between, kind of like semi-structured. We looked at a website that does a nice job of talking about these, but the key point: structured decisions typically can be made using technology. So a structured decision is, once you have 5 readings over top of a certain amount, you can have the technology, computer systems, do something, stop production. If you're keeping track of, let's say, the temperature inside the freezers at high V, if that temperature gets above a certain threshold, you can immediately notify somebody to come and check the freezer, because there must be something wrong. It's not staying cool. Okay. Technology is very good for structured decisions. Your car is getting near the center lane. The computer can tell the seat to vibrate on the right side to tell you you need to adjust to the left. Chevrolet pickups do that. I've actually seen that work. Right? A car can be backing up, an object could come in behind it, it could automatically apply the brakes. It's a structured decision based on some type of input and some type of data comparisons in the computer. Unstructured decisions: are you going to start selling penny loafers, or what color of material are you going to use, or how are you going to, what's going to be popular, who you're going to marry? It could be an unstructured decision. Okay. And our last thing for the day. This is, we did an example of a relational database management system. And what we did was we used NIAC. It doesn't work exactly like this, but NIAC is a good example, or an example. First thing I'm going to mark here, okay, we built these entities. So we said students is an entity, faculty is an entity, and we use courses is an entity, and then the term or section of what's offered currently. And we could have more of these tables. Then inside the tables, we created attributes. I'll make them in green. Student ID number is an attribute. Birth date's an attribute. Phone number can be an attribute. Gender can be an attribute. Quality points can be an attribute. Credits earned can be an attribute. These all specifically define a student. Address, city, state, zip. That's my abbreviation for that. And so then these attributes the same way. They define courses. The name of the course, how many credits the course is. You notice I didn't put the instructor in there. I left it out. 3 credits, Bca-101, Intro to Computers. Term ID. Now this is an interesting attribute. Course ID, faculty ID, room, student ID. Has to do with this term. Now let's look at how these, well, let's do one more up here. Faculty ID, name, address, salary. All these define or are related to a faculty member. These attributes are called primary keys. They uniquely identify each specific record. So if I was to do this, so I have a record here of information, and this would specifically identify it. Record information, 007, Mike Dirksen, address, so forth. 99, Casey Larson, so forth. Bca-101 identifies this, and here. Now, use a different color again. So then, if you notice here, we can take these primary keys. These primary keys that identify these records, we can put them in another table. For example, course ID. I'm going to change that a little bit. Course ID, down here, it's in another table. So it's a primary key in another table. We're building a relationship between them. And here it's a foreign key. Put this in another table. Down here it's a foreign key. This in another table. Down here it's a foreign key. So then for the term, when we list a particular record here, we can give it a unique number, and then we can list the course number, which then relates back to this course here under courses. And here's all the information for the course, and we just listed here. We can list who the instructor is. Originally I had 007 in there. Up here, what room. We could have a table with all the rooms too. Get it? With all the facilities in the rooms. So then the room ID, the primary key, one of the rooms could be PC229, and then we could list all the attributes about the room, like how many students it can hold, and what features are available, and so forth. Now, so an example here then would be, here we only list the instructor once. Now, if I get called off on a secret mission, all we got to do is change this for the new teacher. And all the other records are good. Or if the class gets moved to a different room, all we got to do is change it here, and then all the attributes for the room are available. Extremely popular way of storing data. That's it for today.